Hi, my name is Zhao Changshan with metric number U2005283. Today I'm going to do the presentation for an article named The Wolf of NameStreet, Hijacking Domain Through Their Name Server. This will be my mini case study for the course WIC 3004 Computer Penetration. The article is from ACM Conference on Computer and Communication Security, ACM CCS. CCS stands for Computer and Communication Security, which is published on the year 2017. This will be all the contents covered in today's videos. First, a short introduction, followed by introduction to DNS, typo squatting, name server typo squatting, bit squatting, name server bit squatting, who is hijacking, preventions, and we will wrap the entire video with short conclusions. Okay, so the functionality and security of all domain names are actually very much dependent on something that is known as name server. When this name server or requests to them are compromised, all domains that rely on them will be affected. Today we are going to learn about normal typo squatting, normal bit squatting, and even the enhanced mode, name server typo squatting, and name server bit squattings. Moreover, we also will learn about the hijacking domain through outdated whois records. All these attacks will seize control over name server requests to hijack the domains. So name server is something that when someone registers a domain name, it can change the details inside the domain name, and all these changes will be stored inside something known as name server. DNS, domain name system, is one of the most important protocols of today's internet. The main function of DNS is to convert something that we can read, human readable domain names, to something that machine can read, machine readable IP address. We have been typing the domain name in the browser instead of the IP address. For instance, we'll type youtube.com, facebook.com, and even google.com in the URL bar. Domain name is something that are easier for us and easier for us to remember. It will stand an important position as a branding effect. For instance, however, we need a tool that is known as DNS tools to convert the human readable domain names to something machine readable, which is the IP address. We all recognize the domain name as a brand which we interact with. All these domain names, the traditional TLDs, are actually still sold for millions of dollars. From a security perspective, domain names and their properties are implicitly and explicitly trusted by the users. Okay, now we'll look at an illustration of the DNS resolution process for a client that tries to connect to the host spectrum.um.edu.my. So initially, the client will type in spectrum.um.edu.my in the URL bar. This will then be passed through into the recursive reserver. So this is an example for someone that does not use cache. After that, the recursive reserver will pass it to the root name server. Root name server gives some reply. Then the recursive reserver will pass to the TLD name server. TLD name server will again give some reply. After that, it will pass to the second level domain name server. Second level domain name server will then reply with an IP address for the spectrum.um.edu.my. Recursive reserver will then pass this IP address to the client. Finally, client will be able to connect into the particular spectrum.um.edu.my IP address. Next, typo squatting is the act of registering domain names with some typographical errors of the authoritative domains. Now we have to know something that is known as the black hat, who also we know as typo squatters, will then register this typographical errors domain name with attempt to attract accidental visitors that mistype a domain name in their browser's URL bar. Sometimes we do it very fast and we didn't even notice that we have mistyped the domain names. This will result in an attack that is known as typo squatting. As an example, a typo squatter has registered twitter.com, the fake one, instead of twitter.com, in the hope of getting a share of twitter.com massive amount of traffic. Next, we'll talk about another type of typo squatting, something known as name server typo squatting. Name server typo squatting is actually totally different from the normal typo squatting and is more enhanced. In this scenario, it's actually the administrator of the domain that mistyped the DNS record while setting up the DNS configuration of the domain, which usually happens through a web control panel or even the API registered by the registrar. So when someone bought a domain name, he will be able to change the various settings regarding the domain name. These include a records and even others. All these changes will then be saved into one name server and eventually be replicated to various name servers through the DNS process. To illustrate this, we will take the case of Polyshop.com. So we can see that there are 4 name servers for Polyshop.com, and we can notice that the DNS administrator for Polyshop.com actually mistyped one of the NS records. So this result, however, the result is still a valid domain name that can be registered and resolved. So what they actually did is they key in .ne instead of the .net. However, .ne is also a valid TLD, which is a Niger CC TLD. So we can verify that this domain is in fact an accidental error by querying the other authoritative name server of Polyshop.com. So for the authoritative name server, it will reply with an IP address of 54.207.32.165. However, for the fixed one, it will reply with a totally different IP address, which is 185.53.177.31. So normally, a domain name will have multiple name servers, and because of the presence of redundant name server, an administrator will likely not notice when a single NS record is actually broken. Okay, in the classic typo sorting, only those visitors that actually make a typographical mistake in their browsers are actually affected. Furthermore, that single mistake will only impact that visitor once. In contrast, the impact of name server typo spotting is persistent for as long as the misconfigured NS record is present. So we can see that the name server typo spotting actually has more damage than the normal typo spotting. We could simplistically assume that the ratio of DNS requests going to the attacker name server is equal to the ratio of name server the attackers now controls. Let's take an example. So we use the Polyshop.com example. We can see that there are 4 name servers for Polyshop.com. So that implies that the attacker will see 1/4 of the DNS requests, as Polyshop consists of 4 name servers. This case holds when one of the name servers is chosen randomly for every uncaged request. This happens when either the TLD name server will randomize the return NS record, or when the client's local resolver randomly choose which record name server to query. However, there has been other possibilities, including one where local resolver use the best performing name server to query all name servers in parallel, accepting the faster response. In these scenarios, an attacker can actually increase his impact by achieving faster response time than the authoritative name servers. Attackers could attempt to launch a DDoS attack, but this is not so possible because it may affect the temporary increase in the traffic. To increase the amount of traffic, they can also manipulate or set a higher TTL value on the raw DNS records that they return, thereby extending their cache lifetime. So we can see that the malicious name server actually set TTL value of its red packet to be more than 10 times higher than the authoritative record for Polyshop.com. Hence, it's clear that name server typo sorting poses an entirely different, complex, and more invasive threat than the traditional typo sorting attack. So in the article, large scale of analysis has been done from the study of top 5 GTLDs, which COM, NET, ORG, XYZ, and Info. We found out that there are 164 million domains. They then generated typo variation for each of the top 10,000 NS DOM. And it was found that there was 900,000 type squatting variation. And to be surprised, there was 5% of this actually being registered. Now we discuss about another type of attack, bit squatting. Bit squatting is something related to the typo squatting attack. However, the main premise of the attack is not human error, but actually hardware malfunctions. Bit squatting occurs due to the random bit flip errors in the memory of device and computers. So this bit flip error will occur due to faulty hardware, extreme temperature, and radiations, and thus are by nature and sometimes is unpredictable. However, bit squatting is still quite a popular attack, and it is being discussed for many times. If this basically alters the in-memory representation of a domain name, it can lead to a request to another domain name. So let's see an example. This twitterdude2.com and this is twitter.com. So The ASCII code for 2 is actually 00111010, and the ASCII code for R is 01110010. So we can see that even there are changes in one bit flip, it will definitely result in the different domain names, and this could be the bit squatting attack. Next, we'll discuss about nameserver bit squatting. Nameserver bit squatting refer to bit squatting domain names that occur before. On the other hand, nameserver bit squatting refer to bit squatted DNS requests to the nameservers. So there are actually conditions to be satisfied for the bit squatting to occur. First, the bit flip must corrupt the domain in an NS record that is or will be accepted by the recursive resolver. Next, the attack can only occur during a DNS resolution of domain name whose nameserver is in another TLD zone. When they are in the same TLD zone, the nameserver IP address is actually returned immediately via glue records and no actual lookup for the NS record is made. And lastly, the big flip cannot occur during transmission, since a mismatch between the DNS request and response in the question section will be rejected by the resolver. After this, we will discuss about the last type of attack, which is who is email hijacking, that is capable of taking over the entire NS DOM by targeting email address listed in the whois records. Nameserver domains can be hijacked by abusing out-of-date and inaccurate information in the whois records. The idea is that either access can be gained to the registrar web control panel or an ownership transfer of the victim domain names can be issued. Both cases allow an attacker to set up a malicious nameserver using the victim's domains. Consequently, the attacker will be able to hijack all domains dependent on that nameserver. The whois hijacking that is the most widely used for abuse is that of email contacts. An attacker can hijack the email accounts listed in a whois record in two ways. First, some webmail provider will expire an account and make the address available again when the user does not log in for a very long time. And therefore, if the email listed in the whois record is gonna to be expired, the register can do something. They will just register the expired email account and do the attack. Don't be surprised because there are actually known cases for this type of attack. For instance, in 2009, an attacker was able to steal the internal documents of Twitter by registering an expired Hotmail account as a way of gaining access to a Twitter employee primary Gmail account. Secondly, if the email account listed in the whois records resides on the domain which has been allowed to expire. For instance, some domain name can only hold for 1 year and even 2 years. So if domain name is going to be expired, then an attacker can register that domain name and set up a mail server to receive email distinct for that domain. As soon as attacker control the email address, they can initiate a password reset with the registrar and set a new password through the link sent to the stolen email address. If a two-factor authentication is not set up, the attacker will then gain access and have full control over nameserver domains. So the potential impact for the hijacking through whois record is actually being categorized into three categories, which is the high risk category, the medium risk category, and also the low risk category. For the high risk category, it includes all domains where the vulnerable email address was actually the registrant contact. If an attacker used the registrant email to gain access to the registrar control panel, they then will have full control over the domain, including the ability to change all other email contacts in the whois records. Next, for the medium risk category, this includes domains with a vulnerable admin email, but not a vulnerable registrant email. Even if it does not directly grant access to the account, control of the admin email could be requesting authentication code from the registrar. So here it will be depending on how strict the registrar about obtaining the authentication code. So sometimes email requires some social engineering. Social engineering is sometimes something that is very popular right now. It refers to someone pretend to be the users and lie to the authorization to get something that they need. Since the admin email is the first point of contact for domain transfer, an attacker could transfer the domain if they are able to obtain an authentication code or if they are dealing with registrar which do not require authentication code for transfer of particular TLDs. Finally, we'll talk about the low risk category. The low risk category includes the domain with vulnerable email which are neither admin or also the registrant contracts. it is unlikely that this email could be used to gain access to the account or transfer domain. However, there is still some possibilities. This come along with being listed in a domain who is, they can use it to obtain an SSL certificate for the domains. We can all see that domain security will be entirely jeopardized when connection to the name server is compromised. Now we'll see some of the preventive measures being introduced in these articles. Firstly, DNSSEC. DNSSEC is actually the most powerful tools and system being introduced in this article to prevent against all those attacks being mentioned earlier. DNSSEC refers to an extension to DNS which provide integrity to DNS by allowing name servers to add digital signatures for their resource records and establishing chain of trust. So we can look at an illustration here. There will be chain of trust here. Okay. DNSSEC, when actually deployed properly, is capable of defending against the attacks described in this paper. This record tells the DNS resolver to expect sign response from the next name server in the chain and contain a hash of the public key signing key for the next zone which is used to verify the source. When an admin actually creates the DNS record, they are adding a secondary reference to the correct name server beyond the standard NS record. If a victim domain points to a malicious name server, regardless of whether it's due to an mistyped NS record typo squatting, a bit flips, or even a stolen control of name server domain, the attacker will be unable to correctly sign its response. With a proper signature generated by the key pairs that match the hash public key in the DS record, a DNSSEC validating resolver will reject and respond from the malicious name server. However, in order for a full DNSSEC deployment to work properly, there are several requirements involving responsibility and even cooperation between various parties. This includes domain owners, name server owners, and even registry and internet service providers. So the complexity of deployment has led to slow adoption despite the age of DNSSEC. Next, the article also suggests the need for additional defense requiring less cooperation between parties that can be updated faster. So to reduce the number of misconfigured domains, the registrar can do something that they check for typos by comparing all NS records that administrators are entering into the registrar control panels. Besides that, the registrar could also require the administrator to enter new NS record twice. So this is something that's similar when we are creating the new passwords. So this can actually reduce the possibilities of mistyped records. For the outdated whois information, the article suggests that the registrar periodically verify the email address listed in the whois record and make sure that those emails are not expired. So now we reach to the conclusion parts. We have discussed several topics in this video. These include typo squatting, bit squatting, name server typo squatting, name server bit squatting, and even the expiration of email address that can be abused to hijack thousands of domain names. Moreover, we also go through some of the preventive measures discussed in the article to prevent against this type of attack. As conclusion, the attack being introduced in this article is practical and actually can be done in the real world. For the name server typo squatting to be occurred, the admin for the domain had to misconfigure the NS record, and for the bit squatting, name server bit squatting to be occurred, it has to be depending on nature. Moreover, the article is actually understood and has taught me a lot of knowledge regarding name server to me. The attack being introduced in the article, when it is being launched, will affect a large group of domains as compared to the typical typo squatting and bit squatting attack, which will only affect one domain name. For this, name server typo squatting and name server bit squatting will affect a large group of users. Hence, the attack being introduced in this article should be aware and actually be avoided. So these are all the reference for the articles and the acknowledgements. Okay, that's all from me. Thank you.